All right, so I want to show you an example of a calculation with dot products that's a little bit different than the way that we've been looking at dot products so far as the magnitude of each vector multiplied and then also times the cosine of the angle between them. So there's another way that you can do dot product calculations, and I want to show you this example. So let's say that we have vector A and vector B, and they're given by these values in I hat, j hat, k hat format in the component form. So let's say that you're given these vectors like this, and they want you to find the dot product. Okay, so first notice that just kind of reminding you that the coefficient to the I hat component, that's going to be a sub x, and then the next one is a sub y, a sub z. Just reminding you of that. Same thing with the b vector. Okay, so if these are the two vectors that I want to do a dot product of, here's the relationship that I get. Okay, so to do a dot product, yes, we already know that a dot b is equal to magnitude A, magnitude B, times the cosine of the angle between those two. That's true. But we're looking at another relationship, and that's this. Okay? So if you have the component form of the vectors rather than the magnitude form, the way to do it is just to follow this formula here. So you're multiplying the x components, multiplying the y's, multiplying the z's, and then you add those together. Keeping in mind that each of these intermediate results, each of these terms, is a scalar. Notice it does not say I hat, j hat, k hat. There's no I hat here, there's no j hat here, there's no k hat here. If we had that, then we would not be able to add all three of them up to get this value at the end of the 1 Newton squared. So this is the way that you can do a dot product if you have the component form of the vector and not the magnitude form of the vector that we used before.